Hey guys, welcome to my channel. So tonight we're doing a little bit of Bedini circuit tuning. If you guys aren't very familiar with it, this is the basic circuit. You have one power wire, one timing wire, which is the second one, and then you have a transistor, and then a diode for the output, and then a little resistor. So this is going to be our little resistor. This is a 25 watt 1K pot, so that we could kind of adjust it on the fly. And yeah, if you guys need another thing to look at, so B1 is the primary battery, which is that one, and then B2 is this one. So the output that comes out, which is this little diode right here, comes through the yellow and white, goes in the capacitor, then through an amp meter, and then it goes to the second battery. This is just kind of a direct way where we could kind of measure what's going on. So right now I have it set up for full power, so it's basically at the very end of it, and then we're going to dim it down, so it's basically right around 50 ohms of resistance right now. So that's going to be, the highest speed and the most power, and then we're going to start dimming it back and be able to look at the scope and see the differences in it. So let's get this fired up. So we're using just a little over 2 amps, 2.13. This is the capacitor voltage, 13.23, and then we're using around 80 milliamps. This is the output going to that second battery over here. So right now, let's check what the RPMs are. So 1212. If you look at the scope, there's only like 1 or 2 pulses coming out the bottom. This is the lowest resistance, so you'd only have like usually 1 spike or 2 spikes in the system. And then so we're using the most amperage and we have the least amount of output, but we have good torque. I mean, this is a 17-inch fan. We're basically doing 25 watts, 1200 RPMs, which is pretty good for a Bedini circuit motor. And so what we're going to do now is I'm going to start backing this off and be able to see the change in it. So right away you can see that more spikes are being generated. Motor's slowing down, amperage is going down, the output is creeping up. I'm going to keep turning it down. So now it's acting kind of like a pulse width modulator. We're getting a lot of spikes in there. Using 0.69, so 690 milliamps, and our output's about 160 milliamps. And I'm going to keep turning it down. It's kind of hard to see on the scope, but that's the best I could do for it. So I'm just going to keep turning this down until we get to 3. So here's half an amp. There's the output. Then we're going to keep going down until we get to 3. So 3, this thing's about a little past halfway, about 3/4, so right around 600 ohms of resistance. And you can kind of see it's just all solid spikes. And you can really hear it. So when we get to 3, pretty much exactly at 3, Turn down just a hair. So 3 right there, and then we're doing 160 milliamps. So right there, you're basically, turn it down just a little bit more. There we go. So right there, you're at 50% energy return. So you're 300 milliamps, and you're about 160 milliamps. So kind of neat, but the motor's definitely going a lot slower now. So you're right around 470 RPMs. And on here, it's pretty much solid spikes between little. Yeah, adjust this a little bit. So kind of neat. We could turn this thing back up and see it change. Go back up to full power. Basically like one pulse in it, but now we got horsepower and torque, but not very much return, you know. So I guess that's just what you want to do with it. You know, if you just want power out of it without timing or anything, it's kind of cool. You could start it either direction. Has quite a bit of torque. This big fan, 17-inch fan, and so basically 26 watts for 1200 RPM. But if you just want to do energy return, then you got to tone this thing way down, right around 300 milliamps or so. But you can get 50% energy return on it, which is kind of neat. So as I turn it up, you can watch the spikes get wider, wider. And full power has like 1 or 2. So pretty neat. So in case you guys are wondering, this is the resistance right here that we're adjusting. This R. It's a little diode, and then this is the resistance we're adjusting right here. So this would be the smaller wire on the coil, and then the output comes off the bigger wire, and then this is a neon light, and then your transistor. This is the circuit. So it's pretty simple. You got the big diode for the output, the little one on there, and then this is the transistor I'm using, and then this is for the resistance, so you could adjust it. It comes out to this pot right here. So thanks for watching.